Assalamu alaikum. I am Abdur Rahman and my roll number is 860181. And today the topic of my presentation is the outer sphere mechanism, inner sphere mechanism, and the factor affecting on inner and outer sphere mechanism. Now we goes towards my first topic, direct electron transfer. First we will discuss about the principle. There can be no appreciable change of atomic arrangement during the time of an electron transition. Means every light electron move rapidly than heavier atoms. The next one is mechanism. There are two types of species. The one is reductant species and the second one is oxidant species. When these species are close together, a precursor complex is formed, which is also known as a solvent shell. And the example of these oxidant and reductant species are given below. The reductant species we use there may be a ferrocyanide and oxidant species a ferricyanide. The bond length of these complexes with carbon are different. In ferrocyanide, the bond length is longer with carbon, and in ferricyanide, the iron and carbon shorter bond length is present. When the complex is formed, the length of bond is changed. Solvent shell. As we will discuss above, how the precursor complex is formed, which is also known as solvent shell. When these two complexes are combined to each other or close to each other, this the complex which is formed is known as precursor complex. The next we will discuss about the features. The reaction slow only due to the following reasons. Electron transfer. When the electron is transferred from Eg to Eg, so the rate of reaction is slow. Different bond length. When metal ligand bond length is different, then the rate of reaction is slow. The example of that statement is there. Here we use ferrocyanide and ferricyanide. The bond length of iron with carbon is different, so that reaction is slow, and if the bond length is same, the reaction become faster. And the feature of fast reaction only due to the following reasons. Inert. Both reductant and oxidant should be inert होने चाहिए. And low spin. Both reductant and oxidant should be low spin, so that when electron transfer from T2G to T2G easily. Means उनकी spins जो है वो अगर slow होगी तो electron transfer easily हो जाएगा. Similar bond length. Metal ligand bond length should be approximately similar. As we will discuss above, when the bond length is same, the reaction become fast. When the bond length is different, the reaction become slow. And here I give the example previously. The next one is tunneling effect. If the both complexes are inert and same charge, so due to the repulsion, not precursor complex is formed. So at this stage, electron transfer only by tunneling mechanism. It's mean that when the both complexes are inert and due to having same charges, means both have positive charges, complex with the reductant is also positive and oxidant is also positive, so both repel to each other, so precursor complex is difficult to form, so the electron transfer is there occurring only by the tunneling mechanism. As I show in this diagram, the first one is metal ligand, then ligand and metals. The electron transfer from metal to ligand, then ligand to the second one ligand, that ligand is the ligand of another complexes, okay, and then to the metal. So this is a short introduction about the outer sphere mechanism. Now we will discuss about inner sphere mechanism. In inner sphere mechanism, electron transfer or bonded electron transfer is a chemical reaction that proceeds via covalent linkage. Means in inner reciprocal mechanism, the electron transfer is only done through the covalent linkage. A strong electronic interaction between oxidant and the reductant reactant, and there is a very strong interaction between oxidant and reductant. In inner sphere electron transfer, a ligand bridge the two metal redox centers during the electron transfer events. The bridge ligands could be virtually any entity that can convey electron, and this mechanism is developed by Tube's classical 1953 experiment, and he also awarded as the Nobel Prize in 1983. The step of formation or occurrence of this mechanism: the first of all, substitution to form a bridge between the oxidant and reductant, and the second one is actual electron transfer, and third one is separation of product, often with transfer of bridge ligands. Now there we will discuss about the mechanism. There are two complexes, means two species, one is oxidant and one is reductant. The first one species is have low spin and inert, the second one is high spin and labile. Okay, when minus H2O, means when water is removed, then this type of intermediate is formed. This intermediate is also known as activated bridge intermediate. Okay, why this intermediate is formed? Why not solvent shell is formed? Because both species, oxidant and reductant, have positive charge on its complex. So due to having same charge, the repulsion is occur, so precursor complex or solvent shell is not formed. Okay, so the activated bridge intermediate is formed. Through this bridge intermediate, electron is transferred, samely as tunneling effect, as we discussed above. Same like that, the electron transfer from chromium to chlorine and from chlorine to cobalt. When electron is transferred, this type of its complex is produced, and then when water molecule is added, these two complexes are formed. Okay, and then when 5 water molecule is insert, then these two products are produced. Factor affecting the rate of direct electron transfer reaction, ये हमारा नेक्स्ट टॉपिक है. नाउ अब हम इसकी तरफ बढ़ते हैं. इलेक्ट्रॉन स्टैटिक रिपल्शन बिटवीन आयंस ऑफ लाइक चार्जेस. बहुत सारे इफेक्ट इसके ऊपर काम कर सकते हैं, तो जो इम्पोर्टेंट है वो हम यहाँ पे डिस्कस करेंगे. तो जो पहले वाला है वो है इलेक्ट्रॉन स्टैटिक रिपल्शन बिटवीन आयंस ऑफ द लाइक चार्जेस. व्हेन एक्टिवेशन एनर्जी इज इंक्रीज, rate of reaction is slow. This is a simple concept. When activation energy is increased, the rate of reaction is slow. This contributes to the activation energy, and due to the electronic static repulsion, energy of activation also increase. Means when the electrostatic repulsion is occur, the activation energy is also increase. The increase in activation energy tends to decrease the rate of exchange of electrons. As an example or structure draw there, and this structure is I also discussed above. The one species is reductant and second one is oxidant, and when is combined together, the precursor complex is formed. Okay, which is also known as solvent shell. When electrostatic repulsion between these reductant and oxidant are increased, the activation energy is also increased, and when these repulsion is decreased, the activation energy is also decrease. Now we will discuss about the identity and concentration of the cation present in the solution. In previous factor, when I say electron activation energy, the rate of reaction is slow. Why rate of reaction is slow? This question is arise. Why? When activation energy is increased, the rate of reaction is slow because the increase in activation energy tends to decrease the rate of exchange of electron. मतलब जब हम एक्टिवेशन एनर्जी को इंक्रीज कर देंगे तो डिक्रीज हो जाएगी रेट ऑफ एक्सचेंज ऑफ इलेक्ट्रॉन की टेंडेंसी. तो ये इसका सिंपल आंसर है. तो नेक्स्ट हम इसको डिस्कस करेंगे आइडेंटिटी एंड concentration of cation present in solution. Increase the concentration of cation, increase the rate, but certain ions are particularly effective in this case. The general effect can be attributed to the formation of ion pair which then decrease the electrostatic contribution towards activation energy. Okay, and the third one is conductivity of ligand. Increase in the conductivity cause increase in the electron transfer between two complexes. The transfer of electron is done through tunneling process of mechanism. This type of mechanism I discussed previously with detail. Electron transfer between variety of similar cyanides have been found to be rapid. The same is true for highly conducting complexes. Okay, the method of this type of electron transfer I will discuss previously, so you can better understand previously. The next one is reorganization energy. When reorganization energy increase, the rate of reaction is decreased. Slow reaction are expected when oxidant and reductant have greatly different bond length, geometries, and solvent shell. The bond length in MnO4 negative and MnO4 -3 are activated complex for exchange between the must involved in stretched MnO bond and MnO4 bond. For octahedral complexes, bond length are changed more drastically when Eg are involved in the transfer as compared to T2g electron in the d orbital. It simply means that when the electron transfer in the d orbital for octahedral complexes, the bond length are changed more drastically. Free energy change in the reaction. The greater of the negative free energy change for the overall reaction, the faster will be the reaction proceeds. This means that when the greater of negative free energy change for overall reaction is present, the faster the reaction will proceed. So this is a brief introduction about outer sphere mechanism, inner sphere mechanism, and the factor affecting on these two outer and inner sphere mechanism. So if you have any question, you can contact me.